When you know your answer has a top part and a bottom part, you have to hit this fraction button first, and then you can type in the top part is 81y. This next button is the exponent, so y to the 12th. And then on the bottom, we have x to the 20th. So x raised to the 20th. On the practice test, you can check your answer for every problem. There are a couple problems where it's not checking the answer correctly. I tried to fix them, but because I've already assigned the practice test to you, I couldn't fix them. I have assured that those problems are scoring correctly on the actual test. Okay, the next question. Okay, this one, a lot of people were a little bit confused about the format of this question. This is x to the 5th over 1. So really, this is just a fancy way of saying x to the 5th over x to the 12th. Don't let the formatting of that freak you out. It's x to the 5th over x to the 12th. We would subtract to get x to the negative 7th. So this is 1 over x to the 7th. So fraction bar 1 over x to the 7th. This is one of the problems that is grading incorrectly right now. I have made sure that it is grading correctly on the test. Apparently there's like an extra field or something in the answer that, yeah, if you got 1 over x to the 7th, you are correct on that problem. Okay, number 3, looks a lot crazier than it is. You need to multiply everything on the top together. That will give us 90. 18 times 5 is 90. X times x to the 5th is x to the 6th. Y to the 3rd times y to the negative 4th is y to the negative 1. On the bottom, 5 times 9 is 45. You don't add the numbers, you are still multiplying. You're multiplying the numbers. When you multiply x times x squared, you add the exponents, so x to the 3rd and y to the negative 1. Do you see how the top and bottom both have y to the negative 1? Yes. Yeah. The 90 over 45 is still just normal numbers. That is 90 divided by 45, which is 2. X to the 6th divided by x to the 3rd. These 3 cancel out 3 of the 6, leaving you with 3 left over. Or you can do 6 minus 3 is 3. So 2x to the 3rd is our correct answer. And we type it in, 2x raised to the 3rd. Okay, this problem we see parentheses. What do we do with the exponents when there's parentheses?
Multiply.
Multiply. And use your calculator. 2/3 times 3/4. You should end up with, once it's simplified, 1/2. So your answer is 3 raised to the 1/2. So fraction button 1 over 2. The next problem. This time it's multiplying. What do you do with the exponents when you're multiplying? Add them. 1/2 plus 2/3. Again, use your calculator. You can do all of that fraction, addition, whatever in your calculator. This should be x raised to the fraction 7 over 6. The next problem is actually almost identical to this one. It just looks a little bit different. It's the square root of 2 times the 4th root of 2. You cannot combine square root of 2 and 4th root of 2 because those radicals are not the same. But you can convert this one into 2 to the 1/2. I don't know if you can see that very well. And the 4th root of 2 is 2 to the 1/4. Now it's just like the previous problem. You need to add those exponents together. So this becomes 2 to the 3/4. Now I have set the test so that if you type in 2 to the 3/4, you will get the problem wrong. Because you can't leave your answer like this, because that's not the format that we started with. We started with radicals. So you need to convert this back into a radical. The answer is the 4th root of 2 raised to the 3rd. I want you to see how to enter that in here. So you need parentheses. The 4th root, look over to the right. You see the square root symbol? And then next to that it says n and then a radical. That's the nth root. So you want that one. And then you can type in that this is the 4th root of 2. And then outside of the parentheses, raise it to the 3rd. This particular problem, I will look through question by question. I can grade by question on this thing. I will look through, and anybody who misses this problem, I will look at your paper and see what you have on your paper. And if it looks like what I know is the correct answer, but you just didn't get it entered correctly, I will go ahead and give you the credit. You cannot combine radicals using addition unless the radicals are completely identical. So the first one is the 3rd root of 48. The second one is the 3rd root of 6. So we currently cannot combine them. But we can take the 3rd root of 48 and simplify it. So if I go over here, the 3rd root of 48, we need to split that into the 3rd root of something that is on the chart times the 3rd root of something else. Over here gives you a huge hint about what one of those is going to be. We really want that one to be the 3rd root of 6. What is 48 divided by 6? 8. And the 3rd root of 8, ta-da, just happens to be on our perfects chart. It is 2. So the 3rd root of 48 simplifies into 2 times the 3rd root of 6. So this thing is really saying 2 times the 3rd root of 6 plus 4 times the 3rd root of 6. Now that it's written that way, what is our answer? 6 times the 3rd root of 6. So 6, your little nth root thing, so you can type in the 3rd root of 6. Okay, this problem, if you look at my answer key on the website, I have tried to show you how to simplify each part of this. There we go. And I color coded it, and I tried to like put detail in there about, hey, you can't have this radical on the bottom, blah, 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 blah. So I really encourage you to look at my answer key, at the attached pages to my answer key to see this one. Basically, you end up with 2x times the cube root of x over y squared z times the cube root of z squared. So that's the original after you've simplified it. This cube root of z squared is a problem. This needs to be the cube root of z to the 3rd. So we need another cube root of z stuck in there. So on the top, we will have 2x times the cube root of xz. On the bottom, we have y squared. We have this z, and then this has completed a group of 3, so that is another z. So we have z squared on the bottom. Okay, you know there's a top and a bottom, so we need the fraction button. 2x. Then you type in the 3rd root of x. There's not a z button. You can use your computer and type in z. I'm going to see if I can add a z button because that's kind of annoying that there isn't a z button. On the bottom, y squared. And then you have to push the right arrow to get out of the exponent and then type in the z on your keyboard squared. And this one on here is currently not checking it correctly. Oh, hey, now it is. So it did. I was able to fix that part of it. There's 2 different ways that you can write this, but I think our way is the better way. Let me just go back to that. Like that. Okay, number 9. The cube root of 24 will simplify into the cube root of 8 times the cube root of 3. So that's 2 times the cube root of 3. The cube root of x to the 12th becomes x to the 4th. The cube root of y to the 10th, there are 3 full groups with 1 left over. The cube root of z to the 8th, there are 2 full groups with 2 little z's left over. All of that gobbledygook. You start with the stuff that's not under a radical in alphabetical order. So first we want to write down 2x to the 4th, y to the 3rd, z squared. Then we write a cube root symbol and we put everything that is left under the cube roots. We've got a 3, a y, and a z squared. So that is our correct answer. Let's type that in. 2x to the 4th. Got to get out of that exponent. Y to the 3rd. Get out of the exponent. You'll have to type in the z squared. Get out of the exponent. Nth root button. Make it a cube root. And then 3y. Type in your z squared. I will see if I can add a z button. If I can't, can you all type it in your computer? There's a keyboard with a z button on your keyboard. Okay. Number 10 is the first multiple choice. I would still recommend that you show your work even on the multiple choice problems. If there's not enough work on your paper, feel free to grab a blank sheet of paper. I'll have some blank paper there. The one that I really wanted to go over was this one. It will be slightly easier on the actual test. I think on the test there isn't a 2 in front of the x, which just makes things easier. But your first step is always to get whatever has the exponent by itself. This is. So our next step is to take the 6th root of both sides. So on the left, we have 2x minus 7. On the right, we can't do the 6th root of 120 using our chart, so you have to use your calculator, and you'd get 2.22. If you don't know how to do the 6th root of 120, please see me with your calculator, and I will show you how to do that so that you feel prepared for tomorrow. What did I forget to put in here in front of that 2.22? A plus or minus. Anytime that you take a 6th root in an equation, you have to put that plus minus. Okay, this is the best way to think about this. You've got 2x minus 7 equals positive 2.22, and you have 2x minus 7 equals negative 2.22. Take this thing and use it to split into 2 separate equations and solve both equations. That's going to help you to get this as your correct answer. Okay, so that one's your correct answer for that. And I think that's the last one. Oh, the very last problem. I wanted to go through the very last one with you in my last minute. On this one, this is the last problem. Whatever the denominator is, you multiply the top and the bottom by the exact same thing except the opposite symbol. So if it's originally minus, you multiply by the same thing but with the plus instead of the minus. So distribute on the top, double distribute on the bottom. Those middle terms will always cancel out, and on the bottom we have 64 minus 6, which is 58, and that should help you see which one is your correct answer.